In the race to dominate the future of electric vehicles, a new battle is heating up, one that pits Tesla's game-changing 4680 battery against Toyota's bold leap into solid-state battery technology. It's a showdown between two battery titans, each representing a different vision for the future. On one side, you have Tesla, already mass-producing the 4680 with thousands of units rolling out daily. On the other, Toyota, making waves with promises of a battery so advanced it could charge in minutes and power a car for nearly 1,000 miles. It all started with a bold statement from Sandy Munro, a respected EV expert, who called solid-state batteries the kiss of death for gasoline and diesel, because they could power an EV for over 1,000 miles on a single charge, something that would have sounded like science fiction just a few years ago. And with Toyota at the forefront of this technology, it's no surprise they're feeling confident enough to challenge even the mighty Tesla. Toyota's ambitions are no secret. They're aiming for a battery with 700 miles of range and a charge time of just 10 minutes. That's not just an upgrade, it's a complete transformation. They believe this breakthrough could make Tesla's 4680 battery look outdated, and if Elon Musk doesn't shift focus soon, he could fall behind. But here's the thing. While solid-state batteries sound like magic on paper, real-world production is still full of challenges. So the question is, who's really leading the pack? Right now, Tesla's 4680 battery holds the crown. With over 500,000 battery cells being churned out daily and already powering the massive Cybertruck, it's the most commercially viable high-performance battery on the market. But that doesn't mean the threat from Toyota or others like Samsung, Solid Power, and QuantumScape can be ignored. To understand the real difference between these two battery types, it helps to zoom in on what makes them tick. All EV batteries share four core components: an anode, a cathode, a separator, and an electrolyte. Most current batteries, including Tesla's 4680, use a liquid electrolyte to move lithium ions between electrodes. Solid-state batteries replace that liquid with a solid material, and that one change could be a game changer. Tesla's 4680 battery, first unveiled in 2020, is a cylindrical lithium-ion battery that stands 80 millimeters tall and 46 millimeters wide. It uses a nickel-heavy cathode and a silicon anode, which helps improve energy storage. What really sets it apart is its tabless design, eliminating the little connectors inside the battery that typically slow down performance. This design reduces resistance, increases energy density, and speeds up production. It's also cheaper to manufacture, which gives Tesla a huge edge. On the other hand, solid-state batteries take a very different shape and come in several forms: prismatic, pouch, and even ultra-thin formats for smaller gadgets. Their electrolytes are usually made from oxides, sulfides, or polymers. These materials allow for higher voltage, better thermal stability, and potentially far greater energy density. And speaking of energy density, that's where the war gets interesting. Tesla's 4680 delivers up to 350 watt-hours per kilogram, about 30% more than older lithium-ion models. That boost means Tesla cars can go farther while weighing less. A Tesla Model 3, for example, could jump from 363 to over 470 miles of range just by switching to 4,680 cells and shed a few hundred pounds in the process. But Toyota isn't playing small. Their next-gen solid-state batteries are targeting 600 watt-hours per kilogram, almost double what Tesla currently offers. If they pull this off, their EVs could hit ranges of 750 to even 923 miles. That's nearly the range of a gas-powered car, and that's the goal: EVs that don't just match internal combustion, but blow them out of the water. Still, range is only one piece of the puzzle. Charging time is another, and one where Toyota claims a major advantage. Their prototype solid-state battery can reportedly charge from 0 to 80% in just 15 minutes, almost as fast as plugging in a smartphone. That's enough to make any EV driver stop and take notice. Tesla's 4680, meanwhile, can charge up to 60% in around 20 minutes and reach 80% in 30 minutes using high-powered superchargers. Impressive, but not quite the speed Toyota's promising. Yet there's a dark side to all this rapid charging. Solid-state batteries face a nasty issue known as dendrite formation. tiny lithium spikes that can grow through the solid electrolyte and short-circuit the battery. And because fast charging accelerates this problem, Toyota and others still have a lot of work to do to ensure their batteries won't fail after repeated use. That's where Tesla's 4680 wins some points. Its stable design and better heat management reduce the risk of internal failures. In crash tests, even when Cybertrucks were severely damaged, the batteries rarely caught fire. That's thanks to Tesla's clever engineering, thicker steel casings, integrated cooling systems, and a safer tabless design. But since it still uses a liquid electrolyte, it's not immune to all the dangers. Solid-state batteries are generally safer in theory because they eliminate that flammable liquid. No leakage, no swelling, and lower risk of explosions. Still, nothing's perfect. These batteries can still overheat or fail under extreme conditions. And that's not even the biggest hurdle. They're expensive. Solid-state materials like lithium sulfide cost 5 to 10 times more than standard lithium compounds. Producing them also requires ultra-clean labs, special humidity controls, and manufacturing techniques that aren't yet ready for mass scale. Even Toyota, despite claiming it can cut costs by 50%, still admits that solid-state batteries won't be cheap anytime soon. Then there's the problem of scale. Making a solid electrolyte layer thin and consistent across every battery is incredibly difficult. Most companies haven't gone beyond lab tests or small prototype batches. That means even with amazing specs, these batteries aren't quite ready for the roads. Meanwhile, Tesla is already producing the 4680 at scale and planning to hit 1,000 gigawatt-hours per year, with battery costs potentially dropping below $70 per kilowatt-hour. That's a price no one else is close to right now. So what's the verdict? Toyota's solid-state batteries are promising, maybe even revolutionary. With higher energy density and faster charging, they could eventually leapfrog over Tesla. But right now, they're expensive, difficult to produce, and not yet road-tested at scale. Tesla's 4680, while not as futuristic, is here today. It's charging faster, powering actual cars, and being mass-produced efficiently. That gives Tesla a big lead, not just in technology, but in real-world readiness. In the end, both batteries represent different phases of the EV revolution. The 4680 is the present, fast, scalable, and smartly engineered. Solid-state is the future, brighter, maybe, but still on the horizon. The real question isn't who wins today, but who's best prepared to lead tomorrow.